So good evening once more, everybody. I'm happy to have everyone here on the call. And last class, I promised that I was going to start this class with Silvano's question. He asked a question yesterday, and I told him that he said he had a problem understanding something. And I told him that that would be the first thing we'll be discussing in today's class. So I don't know if you still have your question, Silvanos.
Yes, I had two questions. Yesterday you said you're gonna do match. You're gonna use match instead of what if on the first part of the assignment. Then my other question is I didn't understand question two, which says write the function that takes the vector of integers. So the process that you're doing, I didn't quite get that.
Okay. So just to be clear, your question is based on match operator. You really don't understand the match operator, and then you did not get the other function I created, that process vector function, correct?
Yes, the other one you created, the one you said it's a simpler way of doing it.
Okay.
Yes.
Okay. Yeah. So I'm going to share my screen now, and I'm going to go back to it. So if I'm correct, here's the function that I created for the process vector. So this function, I made mention that it's a completely different way of doing it compared to what Edrin shared on our screen yesterday. So for this, all I did was I used a method called iter. Now this iter allows me to get access to certain methods for a vector. So the iter methods as the sum, as mapping, as filter, as so many methods for different things. Now, all of these things we are going to talk about in a later lecture. But due to the fact that Edrin showed a method of basically, creating a new vector here, creating a new sum equals 0, looping through it and, adding up like that, I was like, okay, that's the method. That would have been the method I would have used to explain this. But since he used that, I was like, let me create a different method for us to also, expand our knowledge. So what this does is it takes this vector, you can think of it as a dynamic array, then it converts it inside an iter. So it converts it into an iterator. So after converting it into an iterator, it then have access to certain methods, certain iterator methods. And all of these methods, this is not the class we are going to talk about it. This is just like a preview of what we are going to talk about when we get to iters. So then the next thing I did was I created a for loop, and in the for loop, I made sure that I looped through this vec. Then I did something else. I dereferenced it here, and then I multiplied and equaled it into what I wanted it to be. So each particular element in the vector is replaced by this new solution. So that's what I did. And after doing that, I basically returned it. So that's all for that. So moving on to the calculator. Calculator is the next thing we were meant to do, but we did not do yesterday. Okay, so for the calculator, we are going to take in two inputs. Let's say we want our calculator to be able to perform operations on two inputs. So let's say we have an F64, then B should be also an F64. Then the next one would then be an operation. What's the operation? The operation is basically whether it's addition, subtraction, multiply, or divide. That's what we want to do. So for this operation, we're going to use string slice. Now, remember what I said yesterday? I mentioned that I was going to introduce something new to us today. Enums. Now, I know I've not spoken about enums in this class, but I'm going to use it as a preview of when we will be talking about enums. Now, when we are talking about enums, we definitely talk about struct. Now, there's high probability that in our previous class, I must have touched it a little, but I have not actually touched it. Now, this is what an enum look like. Let me create it. Enum. You can have enum traffic lights. Traffic lights here. And inside of it, you can have red, blue, green. Oh, sorry. Traffic light is red, yellow, green. That was a mistake. This is what an enum look like. So this option is an option enum. Now, this option enum comes from the raw standard library. It just looks like this. This is what the syntax looks like, technically. Now, out of the option, an enum could also have probably a data type inside of it, I32. It could have a data type inside of it. It could have something like this. So, but in essence, this is what an option enum looks like. So, an option enum contains two things. It contains whether the result is a sum value or the result is a num value. Now, we can think of JavaScript, for example. Now, for JavaScript, there are particular situations whereby a value could be null. So at what point is a value null? This can pose a situation in JavaScript that could lead to a whole lot of debugging. Now, Rust was able to solve that problem using an option enum. So the option enum contains whether the result is a non-value or the result is a sum value. So in this case, as you can see, the option enum have something here. This is called a generic. Don't think about it for now. We're still going to talk about it. This is a generic. Now, it's also all have inside of it the none and the sum. So you can have two results, just like the results. Where is the result that I showed? Did I give any example of results? Okay, yeah. The results. Yeah, let me put on it. Just like the result enum that has an okay value or an error value. The sum, the option enum also have a none and a sum value. So this none and sum, we can then, structure it, match it, and do anything we want to do. And that is what is making me introduce this option. I could as well use results. So let's go. I'm going to remove this now as we don't need it. And then let me remove our to-do. So to start with, I'm going to use the match keyword. So the match operation keyword, we are going to match operation. I mean, it's literally operation. Now notice, to use the match keyword, you need to match just one thing, in our case, this operation, with several conditions. So this operation, we are matching it with what? First of all, we open the curly braces, and then we start matching it with what? With add. The add operation is the first one. So we make an arrow, then we destructure this into sum, and then we say if it is add A plus B. Now we also do subtract. If it's subtract, we have our sum, we have A minus B. Now, if it is multiply, we have our sum, we have A multiplied by B. Now, if it is divide, a situation can come up. So in that case, while we are doing this, we can in fact still make some conditions. For example, We can say if b is not equal to 0.0, I mean, it's a floating integer, do something. We want to say sum a divided by b. Else, something should happen. What should happen? Let's add the else here. Else, we should return none. Now, the last one is, notice we still have a problem here. The problem here is that we have addition, we have subtraction, we have multiply, we have divide. Now, what if there's a situation whereby what we are returning or the operation we are passing in is not part of this add, subtract, multiply, and divide? We want to undo that situation too. That is exactly the benefit of using the match operator. So the match operator allows you to use this underscore. This underscore would cover scenarios for other operations that basically is not involved. So for other conditions that does not include add, subtract, multiply, and divide, this is exactly what will happen. This underscore is going to cover for that situation. So in that case, we want to return none. So if something is wrong, we want to what? Return none if the operation is not part of it. So it's just basically going to return none. Does everyone understand what I've just explained? Good. Wisdom just made mention of something. It reminds him of switch case. Exactly. You can think of it as switch case. Now, someone is putting thumbs down. Who is that? Can you unmute and ask your question?
Good evening, sir. I don't understand the undefined part. Like what is returning like the from the I can't okay, here's the code. From the side of none and if B is not equal to zero something.
Okay. Okay. Let me put this like this. So you would, if it would make it better for you to see. Okay. Now, we have a situation of divide. That's division. Now, for division, we have established from previous class that if you divide 2 by 0, it is undefined, right? Beulah, are you there with me? Okay.
Yes,
If you,
sir.
if you divide 2 by 0, it is undefined. According to mathematics, Abi, it is undefined. Now, if you divide any other number 2 by 0, it is still undefined. Now, in this particular case, we have to undo that situation. So how do we undo it? We introduced an if-else statement. So now, we now went to the condition for divide. So for divide, if b is not equal to 0.0, that is the denominator. If the denominator, or let's just rename this to numerator, and let's name this one to, you know what? Let's just not denominator. So we have to remove it from here. Okay. So then for this one, let's just change this one. But would it even make sense? I mean, numerator and denominator is literally for only fractions. But we are not dealing, everything is not fraction. So let's revert back. Everything is not fraction. It's only this one. It's only when the situation is divided that it's fraction. So in that case, I'm saying that if b is not equal to 0, that is, if the denominator is not equal to 0, then, you are free to go. Do your division perfectly. Else, return it as a none. We can convert this to also say, if b is equal to 0, return none. And then we will now say, else, divide it. This also works. So any way you want to do it, you understand. So that's basically it. So does Sange understand that, or is I meant Beulah? Do you understand that? Okay, great. So with this, you remember we could make use of if-else statements here. We could create a function calculator, and we would have basically everything here. So let me just copy all of the things here. Can have everything here, and then down here we could say if operation is equal to add, just do this. Else if operation is equal to subtract, just do this. So we can basically have this. What's the problem we are having? The name calculator is defined multiple times. Oh, that leads us to something else we are going to talk about later. A situation whereby you cannot have function overload, whereby, some programming languages, like for example, Solidity. Solidity allows for function overloading, whereby you can have 2 or more functions have the same name, but then what will differentiate them could be the number of the inputs, that's the parameters, and then you are making use of function overloading. But in our case, let's just add _1 here. So this basically does the same thing as this. So let me bring this down so we can see it clearer. So between this one and this one, which one would you prefer? So that is left to you to decide as to what you rather prefer between the two. So we would move on. Okay. So I don't know, should we test our functions? Let's test our function. Let's IO tax equals, let's calculate IO tax. So if IO is earning 10 kobo or $10, should he pay tax? Okay, do you know why we have error here? Because it's not a floating point. So this is perfect now. So we can print IOS tax is this, and we can print it. Now, also, we can also create this process vector. For process vector, we can now notice that this particular process vector, it is returning a tuple of vec 132 and vec and ordinary I32. That's signed integer I32. We can do something. So I'm going to do something that will explain something new to us. So we can say vector 1 is equal to, we have where is it? Process vector. And inside of the vector, we can create a vector using the vector macro. We can use 1, 2, 3, 4, 5, like this. Now notice that this is returning a tuple like this, right? This is one method to do it. So for us to have access to the first and the second one, we would say let's first vec. Let's name this one first vec equals vector 1.0. So vector 1.0 is going to destructure this vector 1, and it's going to give us, if I let me change the name. So this 1.0 does not, let's name it main results. We're going to say main results dot 0. So main results dot 0 is going to give us the first result of this. Where is it? First result of this process vector. That's this one. Then for the other one, we're going to use let the sum equals main results dot 1. Now this is an overkill. What we have just done is we have just picked out each of the values from this result, right? We have just picked out the different values from this result. What if there's a better and easier way for us to destructure this? Remember from the tuple class, when I was explaining the tuple class, let me comment this out. I spoke about destructuring a tuple. So what if we say, we open the tuple and say first vec the sum. I like putting underscore at the middle, equals this. Can we see? This basically is destructuring what we have here. So for this is a vec 32, vec I32. Oh, I named this vac. Okay. And this is an I32. Oh, sorry. Let me remove this. Let me remove it from it. We don't need it. We literally don't need it. So this is basically it, as you can see. So we have destructured this particular tuple. We have destructured this tuple without having to, take them out one by one here. So all we had to do was create the tuple, then rename the variables, the results we are trying to destructure, and then we say it's equal to whatever we are trying to call. And just like that, we have destructured it. And for that, you can also do the same thing for the calculator. Although in our calculator, we are receiving an option. And so for the option, you could do something. So you could either get the result and match the result, or you could basically use unwrap. Now, I don't want to get into that now because I know there will be more questions as time goes on. So instead, I'll rather stop here and then we can proceed to what we have in our class. So based on this, is there anyone having any question based on this? Anyone having any question? Okay. So no question would signify that every single person is on board with what is going on. This leads us to going back to our slide and continuing our lecture. Function overloading. Function overloading is what I just explained. ROS does not support function overloading directly. Alternative, you can use different function names or enums. For example, the example I showed you when I was creating this calculator function, where I did calculator, I could have, assuming it allowed function overloading, I could have had calculator, but it doesn't allow. So you basically have to use different name for the function. The next topic we'll be talking about today is closures. What are closures? Closures are basically anonymous functions that capture environments. What does this mean? This means that, first of all, closures are also functions. If you think of closure, for those coming from a Web2 background, you can think of arrow functions. Now, in arrow functions, you don't need to write out function in full. You don't need all of those threads. All you just need is to use the equal to and the greater than sign to make an arrow for you to create your function. You add parentheses, and then if it's a one-liner, you don't even need curly braces. Now, that's arrow function. Now, these closures also work the same way as arrow functions work. So these closures, they are more like anonymous functions that you can use inside of certain methods. So let's say you created a function. Now that function could also have another function inside of it. We are going to get there, but I'll not use that to explain it here. Instead, I want you to understand that there are different methods, especially array methods, I would say vector method, that comes from iterators. And these methods like mapping, filter, sum, that I've just made mention of, there's so much more. All of these methods, you can use it to perform different action on a vector that has been converted to an iterator. All of these actions can be performed through using these particular closures. So sometimes you would see certain methods, iterator methods, that you would use a closure for. So having understanding as to how a closure works would basically help you understand it. So let's look at what a closure is by giving an example. Now we've exhausted all of this. Let's comment it out. And yeah, let's comment all of this too. Okay. So what do we have here? I'm going to say let's call it close. I just shortened the name closure to close. So we could create it here, and here we could say we do this and we say our closure, what we want it to do is we want it to add two numbers together. And then at the back, you just say A plus B. And that is it. So this is basically a closure. But what is more, let's add I32. And yeah, let's also add I32. So this is basically what the closure looks like. So with this closure, it's the same thing as a function. You can basically, let added sum equals close. And inside of it, you can have 10 and 20. And then you can print it out. And you say the sum is added sum. And then if you can run it, let's drag the terminal up a little. Let's clear it. And then we can basically, here's what we did. Can basically cargo run. And then we have our results. Let's wait. It's building. Yeah, it is. The sum is 30. So can you see? Just like you will create a normal function where you would have the function add, and inside of the function you have A and you have B. and even have what it returns as, and then you just, you sum it up. You can do this exact thing is what this is doing, just this one line. But then it is what? It is an anonymous function because this function does not even have a name. We only passed it into this variable to hold it because it doesn't have a name. And an example of a place where it is usually used is, for example, you want to perform certain actions like on a vector. Let me look for a vector we've used before. Okay, we've used this vector before. So imagine for this vector, what we did here for this process vector, where we were creating a for loop and all of this. Did you know that we could also even make this much easier by using an iterator, by literally doing the same thing we did here, but using mapping for it? But I'm not going to do it here. I'm going to just do it here since we have it here. So all we have to do is we can say let results, which we will name res, equal to what? Vec1 dot iter. So this is making it dot iter is literally converting it to what? To an iterator form. So now, after converting it to an iterator, we will use dot map. Dot map is the one of the iterator method where you can basically use to get loop through your vector. Basically, you are looping through your vector and you can basically modify your vector as you are looping through it. So with that, we're going to pass in the anonymous function. In this place, the anonymous function is working on each of these elements, and each of these elements is 1, 1. It's going to take in one parameter, x. And then what are we going to do? We're going to say we are multiplying x by 2. Remember, that was what we did earlier. Yeah, where we multiplied x by 2. Yeah, that's each of these vector where we multiply it by 2. Then for here, after converting it to iterators, we then use the collect, and then we have it back like this. And this, what are we collecting it back? We need to specify the data type. And here it is, basically. So now this, I'm not using this opportunity to teach you what mapping is or what filter is. I'm using this opportunity to just explain how an anonymous function can be used. So this is an example of where an anonymous function is being used. Does anyone have any question based on closures that we have just explained? Can we get thumbs up to proceed to ensure that everyone is in sync? Okay, great. So moving on, we'll be talking about what we call higher order function. You see, this is a very interesting thing about Rust. Imagine a function having a function as a parameter. Now let's even take it further. Imagine a function having a function as a parameter. How interesting could that be? Let's go down to the code immediately to perform some of the magic. Let's the next class, I'll probably just clean up everything on this slate and we start afresh. I mean, already going too far. In fact, let me just comment this and comment the main function and we move down. Let's remove this. We don't need it. So we're going to create a new main function and yeah, we are good. So now, what are higher order functions? Just like I have explained, higher order functions are functions that have functions as their parameter. What are we trying to say? Let's create a function. We have a function add. What function add does is to add two numbers. But function add is so lazy that it does not want to add the two numbers by itself. Instead, it introduced another function to come and do the addition for him. So in that case, to introduce that function, we are going to use what we call generics. So we are going to explain that as we proceed. And then we pass in A, I32. We have B, I32. And then we have a parameter, which is a function, F. In this particular case, F is a function. F is the parameter serving as a function. Now, this F is a generic because we declared it here. So now we are going to proceed by saying what we are returning is definitely an I32. Then on the next line, we would then say where F is what? Is a function. And F as a function takes in an I32, two I32s, and it returns an I32, basically. And so we open our bracket. What have we done here? We have passed in F as a function. F is a parameter. It's a function. Now, we are now explaining and declaring the data types that are involved in F. First of all, we said F is a function. Then we said F takes in two parameters, I32 and I32. We also said F returns an I32. So we declared all of this here, basically. Let me say something. So you can also do the same thing. What I've just done, can you see? Apart from using the where keyword, you can also do everything at the front here, basically. So this is what I did earlier, where I defined the generic here, and then for the generic, let me just add the to-do macro here. So this one stops crying. So at the front here, I added the generic F, and then I came at the end of the function to explain what F is. Then I used the where keyword, and then I said F is a function taking in two parameters and returning one data type. So you could also do the same thing like this. Let me comment this. No, let me not comment it. Let me just create it. Let's say add one. And for add one, we would have F, where F is what? F is a function, and F at the same time is taking an I32, and then it is also returning an I32, and then we start creating the parameters A, I32, B, I32, and then we would have F, which is a function returning what? I32, basically. So these two things, let me add the to-do macro here. So these two things are literally the same thing. These two things are literally what? The same thing. No, let me put this here, and then this here. So these two things are literally the same thing. So in this particular case, we have, what's this? Sorry. Okay. In this particular case, we have both add and add one. These two functions are performing the same action. So now, how are we going to use this function? All we have to do is then say F, we call F as a function, and then we pass the parameters into it. Here too, we call F as a function, and we pass the parameter into it. And just like that, we have higher order function. A function that returns a function that takes in a function to perform an action. Notice that right here, we don't have the addition. We've not added these two. So what we need to do is now to create the original function that we are passing in. This original function would now be main add. We can name it main add. So this main add is going to take in AI32, BI32, and then it's basically also going to return I32, and all it's going to do is add A and B. So let me just remove this one since I've explained this one. It's usually a nice practice to use this one, but you can also use the other one. I just prefer using this one. That is, declaring the generic here and then coming at the back to explain what the generic is all about. So yeah, just like this. So now, how do I use this? I come to the main function. I say, let results equals, then I'll call my add function. Then I'll say add, and I'll say for A, let A be 5, let B be 3, and let the main function be what? The main add. And just like that, we have created an higher order function. Do we all get that? Do we all get that? Are there any questions based on this? Okay. So let me ask you a question. Is it compulsory to ensure that this F and this F here is F because we are using a function, we are creating a function? Is it important? Or can we have other alphabets work here? I want to hear comments. Nobody is raising his or her hand. Okay, Divine, please.
You can use, I believe you can use any alphabet since it's a generic, I think.
Excellent.
Yeah, so.
Excellent answer. You can use any alphabet. That's just the answer. You can use any alphabet. So why do we say that? That is because now you can now think so wide. You can have your thinking, programming is just like you being a demigod where you have clay in your hand. Okay, yes, Inala. Please, you can ask your question.
My question is, I see with the two F's, they are capital letters, and then with the other rest, there are small letters. Does that have an impact on the same way that you're trying to formalize the whole platform?
No, the answer is
Okay.
no. Now, let me
Okay.
rewrite this. Let me use F here, and then yeah, yeah, I'm going to use, I'm going to name this one function. I'm going to name this one function, and then here I'm going to say where this is this, and then can you see? Can you see, Inala? I have named this function. Now remember also for this F, I can name this F G. But if I'm naming it G, it has to be consistent everywhere. Can you see? It has to be
100%. No, I can see.
Eh?
No, I can see 100%. Thank you so much.
Yes, 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 yes. In fact, Rust itself is case sensitive. Rust is case sensitive. For example, if I write this parameter as this, there won't be any problem, but it's going to keep telling me that can you see? Convert the identifier to snake case. Can you see? I should make it a snake case because it is quite sensitive when it comes to cases. It is. That's why you notice that I am using some things for some things. Now, why did I was going on and on about saying that you can actually have more than one generic, more than one higher order function. Should we try it? Now let's try it. Let's remove this one. Now let's say we want to create a function add sub. Notice that all the functions we have been creating are very simple functions, but they are functions that want to help us understand certain concepts in Rust. Now, this concept we are explaining is completely different from other languages. Some languages don't even have any idea of this. This does not exist. But Rust gives us the capability to do this. So now look at what we're about to do. We're about to try to create a function that takes in two functions as parameters. Let's see. So we have, let's name the first one F, and let's name the second one G. You could use any alphabet. I just want to use F and G. So in this case, for this one, since we have already used the where at that place, let's now say where Fn is I32, I32, and it is going to return an I32. But G is also going to be a function that takes in I32 and returns I32. That basically, okay. Have I missed a point here? Okay, yeah, I've not missed the point. Yeah, that returns an I32. And then we cover this and we add this. And this basically also returns an this one, we are going to say this one returns an I32, a tuple I32 and I32. And then it does this. Then we say this one also takes in an I32 and B and I32. And then it takes in the first function, which is F, and takes in the second function, G, which is, no, this function, let's name this function add. Let's name this one to add. In fact, let's name it to add. And this one, okay, this one is F. Then this one, let's name it to sub. So we know what it does is to subtract. Now, after creating this, we can go ahead to now say let add equals to add. And then inside of it, we have A and B. Then we have sub to be equal to sub. And then we will have A and B. And then at the end of the day, we are going to return add and sub. Wow. Can we look at this? What have we done? We have just created a function that takes in two functions as parameters. Can you imagine this? A function that takes in two functions as parameters, and we use both functions, and then we return them. But notice something. For every single thing Rust does, remember that we have not defined this particular function, but we explained what the function would look like. At this place, we said that for the to add function, it must take in just two inputs. So for here, if we remove just one input and give it, if we take out one input and give it just one input, we have a compiler error. Why? This function takes in two arguments, but one was supplied. That is exactly why we defined all the data type and the return type for this function. And in that case, just one function is now taken in two functions, and it can keep growing and growing and growing based on your implementation. I can remember that there was a time back where we created just one function that the function did both addition and subtraction for us. Now look at a different way entirely that we are doing this. So imagine you have a function that is doing so much big implementation, and then you are passing it in to another function, and they are passing another function to another function. All of this process is called higher order function. As you can see, higher order functions. So are there any comments, any questions based on what we have just explained? Any question? You get thumbs up to just proceed. Okay, Sylvanus, please. I guess the class is a little low. Is it because we have eventually entered the coding section and it is now very hot? Remember when I was saying that you guys would enjoy all of these teaching sections where we're talking about what a blockchain is and this. And I said, don't worry, you will be the one that will get tired of the code. You people, don't run away. It's time to write the code. Do not run away. So let's hear from you, Sylvanus. Anyways, tell your friends that missed the class to join the class, because we are moving at a pace whereby we might not be able to go back if someone misses the class. So let's hear your question, Sylvanus.
So I wanted to ask, on the previous, when you're doing higher order functions, you created a main 8 function that it's not necessary even if you just do it like this way. Sorry,
I didn't get the question, please.
So on the previous one, when we did only 2, wanted 2 A and B, you only put
in this one.
Yes. So you created another main function which you said main 8 1.
Yes. 2. Yes. You are very correct. For this one, we also have now, if we want to call this function add sub, we have to create another function. For this, we can name this one main sub. We can just use this function main sub and main add for this particular one. Can you see? So all we have to do is to come to our main, and in our main, let me comment this one. We would create, let's res, I would call it res, which is short form for result. Then I'll call my add and sub function, this particular big function that we created here. And what does it do? It takes in, let's say it takes in 23, takes in 45, and then it takes in main add. In this case, main add is not going to take in parentheses. Then it's also going to take in main sub. And so, here's all we have. Now, we remember we spoke about the structuring today. Where is it? Yeah. We spoke about the structuring. So we could also destructure our result. Since this is returning the tuple, we can say add res, that's the add result, and sub res, that's the subtraction result. And then from here, we can say print the result, the addition is this, and the subtraction is this. And basically, so let's clear this. Let's clear our terminal. And then we can run cargo run. And then what do we have? Can you see? The addition is 68 and the subtraction is minus 22. So we are trying to subtract 23 by 20 or by 45. Result is minus 22. Can you see? That is basically this function working. Can we see? A function taking in functions, 2 different functions as parameters. So that means that we still have to create those 2 different functions and pass them in. So this parameter, this function, you could create another type of add here that does this. But remember, the function data type has to be the same thing. Imagine this one is returning a U32. We are going to have a problem here. Why? Because what we are returning here is an I32, not a U32. So for this, unless you now convert this as I32 before your problem is solved. And now you still have to come up here and change this one to be what? To be U32. Because every single thing has to be the same. Now you still have to convert these ones that are I32 to be what? To be U32. Now, why can't you convert this? It said it expected a U32. You can convert as, okay, let me do this. Let me wrap them together. Good. So at this particular point, you wrapped it up. And so what's the point of me doing all of this? The point of doing all of this is to ensure that every single data type you are using, at every single point that you are using it for the higher order or the function that you are passing it as a parameter, everything has to match. Everything has to be the same data type. So if you are passing in a function that takes in two U32, but then you are now using the function as an integer, your compiler is going to give you a compiler error. So everything just has to be the same thing. So is that gotten? Divine, please.
Okay, I wanted to ask, anytime we create higher order functions, do we have to call it inside a function, or can we call it outside, like separately on its own? Or do you have to call it like that result you did? Do you have to do it inside that function main?
I don't get that.
Like this, let's add res I32, what you did there now.
This
Is
line
it
on
compulsory?
line 306.
Yes. Is it compulsory to do it inside function main, or can you do it outside the function?
Now, if there's a situation whereby you have another function, for example, you create another function here, function get results. And this function, all it is doing is, let's make this one a tuple. You could then basically pack everything that is here. And paste it here. Can you see? Everything is going to work the same way. Because what? This one is passing in this method. Can you see? Everything is going to work. But why I am passing it in the main is because the main is the entry point to our Rust program. It's the point that runs all the code in our Rust program right now, since we are using it in the binary form. We are not using .lib. If you are using .lib, then we'd have to specify where we are running it from. But right now, since we are using the main.rs, we are specifying that we have to run it from here. So if you want to run this function, get results, we have to also do what? Call the, let's now do this. So we are going to just do get results. And then we have it. So can you see? Is it there, Divine?
Yes, I've gotten it. Thank you.
Okay. So this is how we come to the end of our class for today. I'll stop the recording. Oh, Wisdom have a question. Okay, let's hear from Wisdom.
Hello. Thank you for your explanation. I want to ask, is it possible, like since we're creating functions outside of the main, is it possible that we create like a new file that we have, like we house the functions, and then we can refer them in our main file?
Definitely. I love how you are thinking out of the box, Wisdom. Definitely. Now remember that we are still in the primary level. We have not gotten, I know right now, based on what we are doing now, we are already getting to higher level. But yes, you are very correct. Now, in a situation whereby we are building a very big application, all of these functions has to be in different files. Now we have to import all of these files and connect all of these files together. In Rust, you can use what we call workspace pattern. Now, the workspace pattern, we are going to talk about it later on in the future, and especially when we now start building a simple project. Because at the end of the day, the Soroban that is our end goal, we're eventually going to still build Soroban smart contracts that are very large. And this large Soroban smart contract could mean you have so many functionalities with so many, you know, files. In fact, let me stop sharing my screen and let me quickly show an example of a Soroban file. Or in fact, without even showing a Soroban file, I'm just going to show an example of the Rust code that I'm working on currently. Okay, let me just let me bring it here to this Windows. Let me just share my screen, so I'll take it here. I have so many windows on my screen, so sometimes it's just difficult. I hope everyone can see my screen. Okay, this is a different code. Yeah, this is a code base in Rust. Can you see? This is a code base in Rust. Can you see how many files are here? How many Rust files are here? We have so many Rust files, as you can see here. So many Rust files are here. And you can keep opening each one of them on and on and on with so many Rust implementations, as you can see. So just like I made mention of, you can basically have so many files, definitely. So the point is, we are still at the baby level. So let's just continue understanding it before Sylvanus owed something against me. So anyways, this is how we come to the end of our class today, and I would stop recording.